So, this is the second lecture entitled Beyond Hydrology. So, in this particular lecture I would be covering like why we need to go beyond hydrology today to understand water research, to understand water science and to understand the relationship between water and society again towards a sustainable future, which is the sole aim of this course. So, as I mentioned in my overview lecture, the previous lecture setting the context, that very interesting emerging frameworks are coming up today in both natural sciences, physical sciences and also social sciences. So, you can see the first diagram which is called human water coupling, and here it is all about the socio hydrological system or the socio hydrological research, where researchers are actually, or the natural scientists more specifically, they are incorporating society within hydrological research. So, we will discuss in detail about socio hydrology in our next lecture, where I will be introducing you with the cases, the case studies, the case researches and also the the methodologies followed by socio hydrologists today. On the other hand, if you look into the second diagram, it is all about the hydrosocial cycle. So, a very interesting and a strong development within social science research, more specifically within the political ecology of water research in the contemporary times, which actually talks about the how water and society makes and remakes each other over space and time. So, these are the very two interesting emerging frameworks that have come up in the contemporary times, which help us go beyond, or which enable us go beyond the hydrological framework within water science or water research. So, this is the famous hydrological cycle, as all of us are aware of, and this hydrological cycle was designed and conceptualized by Robert Horton, a very renowned hydrologist who is also known as the father of modern hydrology. So, he came up with this diagram with this cycle in the 1930s, and so it explains the natural circulation of water in, on and over the earth's surface. And what is most interesting and important in this drawing or in this diagram is that, so it says that the water cycle or the water engine actually it function in its own way. So, it is fueled by solar energy and it is driven by gravity and it proceeds endlessly with or without human activity. So, human activities can be present or human activities can be absent. So, the absence or presence of human activities actually do not matter. So, what is more important are the technical components within the hydrological cycle, for example, transpiration, evaporation, precipitation and all these other physical components within the hydrological cycle. So, it does not take into account at all the human element or the social science component that is otherwise imbricated in the water cycle. So, again a little bit on the hydrological cycle, and more importantly how hydrological cycle had played a very important role in the emergence of what is known as modern water. A very interesting paper has been published recently in 2010 by J. Linton, and the title of the paper is "What is Water? The History of Modern Abstraction." And there Linton says that hydrological cycle has given birth to modern water, and this idea has continued, has sustained for many decades, at least till the 1980s. So, what is this modern water all about? So, modern water is the dominant and hegemonic way of knowing water and relating to water, which reduces water to a single substance and which render water as commensurable, that is measurable. So, interestingly enough, this idea it actually dates back to the 17th century, the very important period in human history. So, the era or the period of the scientific revolution, because in this particular period it was decided and it was said, it was actually announced that nothing will be considered scientific if it cannot be quantified or if it cannot be measured. So, nothing is scientific or nothing is knowable unless and until it is quantifiable, unless and until it is measured. So, and this entire idea of measurement or this entire quantitative idea to a great extent led to the suppression of all other scientific activities beyond this era as so called quote unquote inexact or non-exact sciences. So, again if we consider mid 18th century, then mid 18th century can be considered as one of the vital moments, as one of the significant time period or a historical movement so far as modern water is concerned, because something interesting took place in the laboratory of Antoine Lavoisier, because Antoine Lavoisier is the person who for the first time reduced water into compounds of hydrogen and oxygen. So, this whole idea that water is nothing but H2O, it to a great extent owes to Antoine Lavoisier and his experiments dated mid 18th century. So, implications and legacy. What had been the implication and legacy of the emergence of modern water, which is again one of the outcome of the hydrological cycle. So, water had actually been reduced to a resource which can then be managed, controlled and hence quantified. So, Baker, again a very renowned social scientist, Karen Baker, he led to the evolution of a particular term or terminology which is called the state hydraulic paradigm. So, Baker says that modern water, as it can be measurable, as it is measurable and as it can be quantified. So, now what happened is that the supply or the development of water supply entirely went to the hands of the state. So, the state became responsible for supplying water to the people, and the government agencies, they became deeply involved to engineer, to control and to manage water resource with some tangible deliverable outcomes. So, that these outcomes are the construction of massive infrastructure, big infrastructure, large infrastructures like for example, dams, and also large infrastructures, large utility infrastructures like piped drinking water. So, what are the major shortcomings in this? What are the problems relating to this kind of a discourse, that has the discourse relating to modern water, that is which is the outcome of the hydrological cycle? The major shortcomings are this, that water then and there had been reduced to its material composition H2O. So, to an extent it will not be an exaggeration to say that hydrology is actually a reductionist science. It is an orthodox science, and different waters have actually been homogenized. So, water have been abstracted, different waters have been extracted from their local context, from the social context, from the cultural context and also from their ecological context. I will explain this in the next slide again. So, again the major challenge or the major shortcoming of this discourse is that here hydrological knowledge seems to be partial, incomplete, it is situated, and hence this kind of a situated or partial or an incomplete discourse or knowledge had led to severe implications so far as policy making or decision makings had been concerned, because these had led to lopsided water management schemes or initiatives leading to environmental disasters, social disruptions and also political protests. So, as I was mentioning about different waters and homogenization of different waters. So, the 16th, 17th century, this is also very important, because if you look into what happened during this time period, if we take a little bit of history, across the centuries, 16th, 17th century, then we find that this is a period when Europe was actually making her transition from the medieval to the modern age. And so, there was a change, there was a shift from the feudal mode of production to the capitalist mode of production, and this was also the era of scientific revolution, the era of transport revolution, agricultural revolution, demographic revolution, commercial revolution. So, here I would like to highlight on 16th and 17th century as also the era of agricultural improvement. So, this is known as the great transition, hydraulic transition in Europe, the era of the great hydraulic transition. Why? Because for the first time a separation was effected between land and water. So, solid liquid hybrids, for example, marshes, for example, fenlands, for example, wetlands, these were all considered as treacherous. So, what happened is that we find during this time, that is 16th, 17th century, innumerable reclamation, drainage, sewerage and embankment schemes were initiated in for example, the East Anglican Fenlands or Italy or the coastal regions or the coastal deltas of the Low Countries like Netherlands, and scientific techniques or hydraulic techniques and hydraulic equipments like pumps, dredging devices, locks, sluices were used to convert and transform once soluble and precarious waterscapes into durable landscape. So, as I mentioned that a great separation was effected between land and water. Rohan D'Souza, he elaborates on this particular point when he focuses on what happened in Eastern India during the colonial times, because he says that this hydraulic knowledge was also, it not only remained restricted within Europe, but it was also transplanted in the colonies including India. So, he has written a paper called River as Resource and Land to Own, which was published in 2009, and then he shows that how different experiments were carried on by the engineers, by the hydraulic engineers, and very much propagated and very much dictated by the state, how the marshes and fenlands and the soil liquid hybrid species in Europe were converted into durable territories, that is land, from where revenues could be easily extracted by the state. On the other hand, how water began to be treated as flows and increasingly sought in contained channels. So, D'Souza writes, land exercise of water was transformed into property, and flowing waters telescoped into contained channels were revealed principally as engineering visions. So, what was the outcome? The outcome is that these regions or these areas like the wetlands or the marshlands or the fenlands, the boglands, if we use the Bengali dialect or if we use the Indian dialect, like there are some areas called chors, which are mainly prevalent in lower courses of deltaic rivers. For example, we have chors or riverine islands in Bengal, in West Bengal for that matter. So, all these areas, these were ignored to be having of any value. So, these areas were regarded as treacherous, these areas were regarded of no significance to the state, because they were not important to generate revenue. The state was only interested in agricultural land, which could provide them lot of revenue through which they could earn profits. On the other hand, the state was also interested with rivers, because rivers would enable the state to provide water utilities, and river would also enable the state to generate hydroelectricity and so on and so forth. So, all these areas like which were neither land nor water, or which were partly land or partly water, the complex realities in these so called land waterscapes were absolutely ignored. So, beyond reductionism. So, what I want to highlight or emphasize is that if we perceive water research, or if we try to understand water by looking into only basing our knowledge only on hydrological research, then we would actually miss lot of complexities, we would actually miss lot of realities which are otherwise very much there within water, or the complex water society interrelations and water society embeddedness, not only during the contemporary times, but which had been there since time immemorial. So, modern water, one of the fundamental differences between modern water and pre-modern water is that while modern water, it has tried to make water undifferentiated, that all waters are similar, all waters are the same, H2O, nothing else. On the other hand, if we really go back to history, if we look into pre-modern water, that is before the conceptualization of the hydrological cycle, then we will understand that, for example, different tribal communities or different ethnic communities, they had understood water in very different ways. So, there are very rich and interesting cultural contexts that had been added to water. For example, if we go through or if we take a look into some of the sources that are represented in the form of cultural artifacts. For example, pictures or paintings in the mud walls of the tribal houses, or the different stories, the folk tales, the folk narratives, or for example, the imprints in the clothes, etc. These artifacts, these cultural artifacts are thickly loaded with different meanings of water. So, while modern water looks into water as undifferentiated, pre-modern water looks into water as differentiated water, different waters having different meanings, having different cultural connotations, having different social realities. So, things are not reduced to quantities, but things definitely have their qualitative values and insights. So, this is what I want to highlight by saying by uttering this particular phrase, that is beyond reductionism, because hydrology to a great extent, it is really a reductionist perspective, which only enable us to understand water in a very linear way. On the other hand, today if we really are able to come up with an integrated transdisciplinary perspective on water, then we will be able to integrate and combine perceptions and understandings relating to water from different fields of discipline. So, if you can see this, look into this picture. So, this is disciplinary silos. So, silos means like these are all isolated, you see there are no connections among this. So, this is the disciplinary approach, where different disciplines, they actually do not talk to each other. On the other hand, there is this multidisciplinary approach. So, multidisciplinary approach means here scholars, they try to combine some of the ideas or knowledge system from different disciplines. So, one disciplinary idea plus another disciplinary idea. So, a combination of several disciplinary ideas and knowledge systems. Then there is this interdisciplinary framework, which is actually interactive. It means that the different disciplines, they actually talk to each other. They talk to each other, they exchange their methods, methodologies, they exchange their knowledge, their ideas and all that. So, that is interdisciplinary idea or the interdisciplinary interactive framework. So, but our aim, our target is the transdisciplinary integrated framework. What is that? So, transdisciplinary means how is it different from interdisciplinary? It is actually different from interdisciplinarity in two ways. So, interdisciplinarity means, for example, within social sciences there can be combination of approaches from history, anthropology and other social science discipline. But again, interdisciplinary also means within natural sciences there can be combination or exchange of methods, methodologies within, for example, physics, chemistry and other natural science subjects. But transdisciplinarity means that there would be combination and exchange and integration of different disciplinary frameworks from both natural sciences and social sciences, and there would be a higher level of synthesis. So, you can see that all the disciplines here, they have become integrated as a composite whole. So, they are not separate parts like this, like for example, in case of interdisciplinary interactive framework, but they have become totally integrated and it has evolved as a composite framework. So, our target is actually to evolve a transdisciplinary framework in river research, a transdisciplinary framework in water research, so that we can understand or we can capture multiple aspects in the interrelationship between water and society, which is the need of the hour today. So, this is another diagram, the pluralistic water research, which Evers et al., Evers and his colleagues came up with in again a very recent publication in 2017, and this is an example of transdisciplinarity, where Evers had tried to combine all the knowledge systems inherent in the different disciplines relating to water research and river research, which he calls pluralistic. So, you can understand, so it combines the multi-layered multilinear understanding and perception on water. So, it is not it's not informed by any singular discipline, but it is informed by plural disciplines across both natural and social sciences. So, this is the target, that how we can really evolve towards a pluralistic river research, not by focusing on different disciplines, or rather hydrology being a single handed discipline, or not even multidisciplines, but combination or integration of different disciplines to a composite whole towards what is known as pluralistic water research. So, this would be our agenda, so that because previously we have seen that hydrological cycle, it has been used, it has played the role of, it has been used as an epistemological tool to disentangle water from its ecological functions and to disentangle water from society. So, our role would be to re-entangle water with ecological and also societal components. So, these are some of the very important references for this particular topic, and the most important being the works by Jamie Linton and Jessica Buds. So, in 2014 an entire issue came up on the hydrological hydrosocial cycle. So, which absolutely criticizes the hydrological cycle and says that today within the era of Anthropocene, no more we should no more anybody practicing water research or anybody involved in water research should be only informed by hydrological cycle, because it is incomplete, it is partial and it is situated. So, there has been a shift. So, one needs to really take into consideration this particular shift from hydrological to the hydrosocial cycle. So, these are some of the references which you need to go through, which would provide you a clear idea that why today we really need to go beyond hydrological research in order to understand rivers, in order to understand water, and in order to understand different waters across different parts of the globe. And also take into account not only the understanding and perception of scholars and experts, but also understanding and perception of local communities, of local ethnicities who also live close by the river system, who also inhabit riparian environments. Thank you.